When I say that Einstein had a complicated relationship with quantum mechanics, I mean that Einstein had a complicated relationship with quantum mechanics. He went from being one of the only proponents in the world for this newfound quantum theory, a major voice, one of the earliest founders of the concept itself, to massive proponent, major player, dynamic guy, interested, to a little bit skeptic, to downright hostile to the entire concept and really the pariah of the scientific community. And towards the end of his life, he would attempt again and again to prove quantum mechanics wrong, with the community just finding out ways to prove Einstein was incorrect, which, can you imagine that job? And the community ending up winning and demonstrating that Einstein's thinking was flawed. What a massive trajectory. So to lay it out here, quantum mechanics really got started right around the year 1900 with a guy named Max Planck studying a certain kind of radiation. He couldn't find a mathematical description for this radiation until he put in just this random factor, a constant that said that the emission of light, the emission of radiation, was quantized, that it didn't come in continuous bursts of radiation. There was only chunks of radiation coming out of materials. He didn't know what to make of it. He thought it was weird. He thought it was an ugly mathematical hack, but it stuck in it. It was the only way to explain this radiation, and so it stuck for years and years, but largely the scientific community was like, okay, Max Planck figured out this like one weird trick, but otherwise the world is continuous, the world is smooth. But then in 1905, Einstein, who is a fan of Max Planck and one of the only fans of Max Planck, realized when studying something called the photoelectric effect that it's not just the emission of light that is quantized, but light itself that is quantized. Einstein was the first person to propose the idea that something physical in our universe is quantized, that light itself is not a wave. It can only act like a wave sometimes. It really, deep down, fundamentally, it is a particle. It is a chunk. You have little tiny chunks of light called photons. This idea was not popular at all. Einstein had to fight tooth and nail to get any attention for it. It was massively controversial, almost, if not more so controversial than his work on special relativity, which appeared in the same year. But the years went by, people started to get a little bit more interested in this quantum theory. There weren't a lot of people were just kind of paying attention to it from the outside and dabbling in it. Einstein went on to make another major advance in the 1920s in quantum mechanics, where he was studying the relationship between light hitting a bunch of gas atoms and what were the various possibilities using these new techniques of quantum mechanics. And he found things like the atoms could randomly absorb the radiation. That's no big deal. He also found that they could absorb the radiation and then re-emit it, something called stimulated emission, which became, the founding theory for lasers. So by the way, Einstein invented lasers. And also he figured out that atoms can just naturally, randomly emit radiation. And one of the problems he ran into when he was running all the numbers and doing the mathematical analysis was that he wasn't able to predict for any one atom where the radiation would go and exactly when it would come off. He could only describe it using statistics and probabilities. At the time, Einstein was a fan of quantum mechanics, but he was under the assumption that all these statistics and probabilities and unpredictabilities were just because we were missing something in the math. And this is a common technique, like, okay, we don't understand the detailed physics, so we're going to average over, we're going to build some statistics around it, so at least we can make a prediction and get some work done, and we'll just figure out the details later. But then nobody was able to figure out the details. And then people started taking this quantum mechanics idea seriously. And then two major advances in quantum mechanics came. One was the Schrödinger equation, which was a wave equation describing the behavior of particles. And at first, Einstein's like, okay, that's cool. We got a little mathematical description going on. It's got some waves to describe the behavior of particles. I got no problem with that. What does that mean? And everyone else is like, what does that mean? And Schrödinger's like, what does that mean? And no one knows what that means until eventually they realize that the waves in the Schrödinger wave equation of quantum mechanics are waves of probability. That these are waves describing where you might find the particle the next time you go looking for it, and that you don't necessarily know where that particle is at any given moment. And Einstein's like, wait. I thought all this statistics, fuzziness, uncertainty, I thought this was just a game we were playing until we figured out the details. But now you're telling me that this is where we're stopping? That we really don't know where a particle is going to be until we go looking for it, and we can only assign probabilities to it. That's giving me a little bit of heartburn. I'm not exactly sure about that. And then the final nail in the coffin, the second thing to come out, was the Heisenberg uncertainty principle, which says many things, but the first thing it says is that you can't perfectly know a particle's position and its momentum simultaneously. The more you know about one, the less you know about the other. And Einstein, that's where Einstein stopped. He's like, nope. We have to be able to understand where particles are in the universe. You've got to be kidding me. You're really saying that there's a fundamental limit to what we can understand in our universe? And Heisenberg's like, yeah. And Schrödinger's like, yeah, I guess. And then Niels Bohr is like, heck yeah. And there ended up being a series of debates going over a couple of years called the Einstein-Bohr debates, where Einstein would try to come up with thought experiments, and Einstein's kind of good at thought experiments, with disproving the Heisenberg uncertainty principle. And then Heisenberg himself is like, I don't know, you beat me, Einstein, I got no idea. But then Niels Bohr like, hold my sandwich, I can figure this out. And he'd like think about it all day, and he'd find a flaw in Einstein's reasoning. And this happened again and again and again. And then finally Einstein gave up. Einstein's just like, fine, you know what? Have your stupid quantum mechanics. I'm going to go work on a unified field theory. You guys have fun. The end result is that by the 1930s, the divorce was final between Einstein and quantum mechanics. He would take to his grave that we were missing something with quantum mechanics, that yes, there may be a limit to what we can know because of experimentation and physical realities, but at the end of the day, nature is not probabilistic. Nature is not non-deterministic. Nature is not fuzzy. Nature is not certain. That there is something deeper than what we know. That quantum mechanics as we understood it in the early 20th century was just scratching the surface of a much deeper, much more fundamental theory. And it could be that because of the way we have to do experiments, we may never know a particle's true position and momentum simultaneously, but he believed we could still write down equations that described it, that were deterministic, that were fully normal physics, none of this quantum fuzziness, weirdness, no probabilities. There was something much deeper down. Einstein spent 20 years trying to find it and couldn't. He devised experiments, something called the EPR paradox, where he said, look, if you really want to believe quantum mechanics, then if you set up an experiment with entangled particles, then they have to communicate faster than the speed of light. Nothing can go faster than the speed of light, and I'm Einstein, I should know this. So either you have to believe quantum mechanics, but in order to believe quantum mechanics, you have to give up the concept of locality, that two particles have to be nearby each other in order to affect each other. And he said, got you there. Turns out we did these experiments and locality is apparently not a thing. As far as we can tell, and we've been working really hard on this, quantum mechanics is it. There's nothing deeper. The universe is non-deterministic and fuzzy and probabilistic at its deepest level. We cannot get around it. As far as we can tell, Einstein was wrong. Oh well, you don't win them all. Thank you for watching, and I'll see you next week. Don't forget to like, share, subscribe, and go to patreon.com/pmsutter. I'll see you next week.